Hello, everybody, and welcome back. Our next speaker is an engineer at Particle by Day, but by night he builds the most exquisite circuit sculptures. And I have to say, as a personal note, what got me back into electronic hacking was actually between maybe beam robotics and doing kind of audio circuit sculptures. So this holds a dear place in my heart, and it's really awesome to see that he's kind of taking this art form and pushing it not just into the present, but actually into the future a little bit. So please join me in welcoming to the Hackaday Supercon stage, Mohit Bhoite.
Thank you, thank you. Good morning. So I gave a longer format talk 5 years ago. I can't believe it's been 5 years. 2019 is when I gave a talk about building circuit sculptures. And so this is more of a, what did I do in the last 5 years? And so it's an update about where I have personally taken this art form for myself and where do I see it going into the future. So this is going to be a very short talk, mostly an update. And if you really want to get into this hobby or this art form, I will check out the 2019 talk at Supercon on YouTube. This is my favorite conference, so I'm super excited to be here. I'm Mohit. If you want to pronounce my last name, it's Bhoite. I work as a senior hardware engineer at Particle. I have been with them for about 11 years now. And it's one of those things where you grow up to become, and nobody grows up to become a hardware engineer, but I love building hardware. And somehow the society said, like, you know what, hardware engineers should be rewarded, and they give us money. And so I have a day job where I build Particle hardware, but then on my free time, I get to dabble in my hobby, which is building free-form circuit sculptures. And by the way, if this is just a Supercon special deal, if anybody wants any free Particle hardware gear, just like come message me. I'm happy to send you free hardware that we build at Particle. So my day job is building circuit boards, and then my night job is taking apart circuit boards and building circuits without circuit boards. And so it has been quite a journey. I did not invent this art form. This has been going on since electronics was invented, when there were no circuit boards. But I did not grow up in the 20s. I grew up in the 90s, where my formative years were the 90s. Internet had just come. I was growing up in India. And so I feel like it was like an exciting time to go into being not connected to being connected. And I feel like 90s is coming back. My first foray into electronics was BEAM. How many of you have heard about BEAM as an acronym? A few of you. So it's an acronym that stands for Biology, Electronics, Aesthetics, and Mechanics. And it was coined by a scientist named Mark Tilden. And he basically took this approach of, could we build seemingly intelligent creatures out of broken Walkman players? I don't know if anybody uses Walkmans, but back in the day, we were using motors and Discmans and electronics that you could rip out of these old gadgets and give them new life. And so the idea is, could you build creatures or robots without actually using microcontrollers? And so that's where I learned free-form soldering, where building circuits without circuit boards. And that was a means to an end. That was not the true art form. The art form was building the actual creatures. You just didn't have access to JLC PCB or PCBA back then. And so you had to build your own circuit boards or build circuits without circuit boards. And so I took this hobby as a teenager. I got into electronics because it was accessible, because I didn't have to buy electronic components. I could just take apart old ones and recreate something new with it. And so I carried on with this. I dabbled in robotics. I got into ham radio and built lots of electronics without having circuit boards accessible. I took a break, and then years went by. I came to the United States, and then I retook this hobby, and I discovered that you could use brass, like 20-gauge brass rods or 20-gauge brass wire, and use that as a media to connect components together. And so I started experimenting. I wanted to take old 7-segment displays, own bubble displays, OLEDs, and trying to connect them together to make them appear as if it was a a sculpture or like a living being. And as time progressed, I tried different techniques. Some sculptures were static, some were animatronic, and some were, mobile. And so over the years, as I started building things, I started to see a pattern, and I'm gravitating towards something that feels like an umbrella, and that was building space-themed circuit sculptures. And you may wonder, why space? I mean, like, why not? Like, as a kid, you look up to the stars and you want to do space travel and you want to build rockets and spaceships, and some billionaires get to do it, but others don't. And so what do? If you're not a billionaire? You basically pay homage to that art form by building things that are inspired by space. But what makes space a good choice for such an art form? I think the answer lies when you just look at them. Sending objects to space is expensive, and so you keep the weight and the mass and the volume to the minimal. So you will see these intricate designs built out of like very, very little hardware. And so I'm like, yeah, this already feels like free-formed, sculpture. So why couldn't I build something, be inspired by this, but in a small form factor? So I combined my background in electronics, my early introduction to beam, and started building satellites. And so these are basically simple inverter, NOT gate-based oscillators, and they act as fireflies, where they will charge all day with their solar panels and then blink at night. No microcontrollers, no programming, nothing required. And these, if you look up online, these are called beam pummers. Don't ask me why they're called pummers, but maybe it's the pattern of the LEDs that pumps in the night. So I wanted to take this one step ahead. Like, what if I started using microcontrollers? And so I used ATtiny 85. That was Charles has been using them as radios. I did not know that. And started building these really, really low power landers and satellites. Now, both of these are the exact same thing, reimagined in different form factors. Like, one is a lander, which is solar powered, and then the other one is a satellite, also solar powered. I think the key here was that LCD display, which only consumes about 10 microamperes when it's actively running. So once charged, these things can run for weeks at a time without seeing daylight. So, but what if I did not have access to these exotic LCDs? What if I wanted to use standard 7-segment displays or bubble displays? Apparently, they are a collector's item now. And what if I wanted to use that? So I experimented with using traditional displays, but they are very power hungry. So solar power doesn't make any sense at that point. So I started using coin cells. Could I make, so the one on the right, these are both glorified thermometers. All they do is measure temperature. But again, imagined in a different form factor. So I started using coin cells and then seeing, like, where can we take this art form? And then, in addition to having displays, like, what if I did not want to have a alphanumeric display? Could I just use LEDs? And so just a simple thermometer, but it will show you the temperature in binary. And so if you know binary, you will know what that temperature is. And then NeoPixels, or smart LEDs, is where you could then display colors. And so that's the next one to it is a VU meter. Basically, it's, again, using an ATtiny, using the ADC, not to receive radio signals, but to receive audio signals. And it's processing those audio signals and creating a VU meter where the LEDs light up and the colors change based on the intensity of the sound. I know somebody I met yesterday had a tie that was doing the same thing, and that was pretty cool. But what if I wanted to use radios, actual radios? And so I started building sculptures that had a BLE radio in it. And so I'm using a Seed Studio's Xiao BLE, which are these like tiny form factor dev kits that are using NRF 52840 SoCs as BLE. And now the interesting thing is, now since we have a radio, we can actually start communicating. So the one on the left is just a next step to the satellite I built earlier, but it's actually sending out BLE beacon packets that the lander on the right is actually picking up. So now the satellite is actually talking to the lander over BLE. And so as in the future, I want to make an ecosystem of these sculptures that are not just static sculptures, but actually are talking to each other. And so I could have this satellite up on a desk and a lander on a shelf, and then a lander on my desk, and they're actually communicating. And given the fact that this can run for 3 weeks on a single charge, means that I can leave it by a window, and it will just, run for perpetuity. And the one on the right is a lithium-ion powered sculpture. It does not have a good lifespan, but it's not a practical product to begin with. And so it just sits, it will run for 2 hours, and then I keep it in a box. The satellite, however, I actually brought the satellite with me, so if you find me back in the alleyway, ask me, I can show it to you, and it's operational. And so if you pull out like a BLE sniffer, you can actually start receiving packets from the satellite. The range is very low because I dialed down the power. So if you're close enough, you can listen to the satellite. But why build something that practical when you can go out and take inspiration from sci-fi? So I started, this is a few years ago, I built these series called the Star Wars-inspired bedside clocks. The wings obviously don't serve a purpose. Outside of them, it's probably not very clear. Looking cool, and so I got inspired by Art Deco, and to see if I can make Star Wars-inspired Art Deco free-formed bedside clocks. And that's something you could build too. Again, space theme, but not necessarily space. And these are the latest lander series. These are using particle products where it's actually connected to the internet and fetching forecast data for your location. So weather.gov, if you give them a grid or a GPS location, it will give you a 10-day forecast. And you can parse that and display it on a tiny little TFT display. But weather is not the only thing you could do. You can do, when's the next rocket launch? Or when is the ISS above me? Or what's the latest value of Bitcoin? Anything that suits your fancy, you can display it, and then display it in such a way that it feels more more space-like. So how do you go about building such a sculpture? Again, I have given a longer format talk on this, so I'm going to run fairly quickly. But I just wanted to give you a glimpse what the process looks like. But before I talk about the process, I laid out some ground rules for myself. These are not universal. These are something that I just made up for myself. And having constraints like this allows me to then, really push what we can do. So the first rule is you don't use electronic components that don't serve an electrical purpose. So no silly resistors used as, I don't know, as legs that are just purely for structure. But there's a gray area. I could use bypass capacitors and say they need to be there because they are bypass capacitors. And you can add as many bypass capacitors as you want, but they're still functional. No glue, solder is your only glue, and so no glue. And then wire, so I try to make all the interconnects with brass or copper. Wires are only used for bringing in power from your USB, or if you have a moving assembly, you could use wires in that case, but mostly rigid copper or brass wires. Notice that I have not said no PCBs. And that is something that you can put as another challenge, like no circuit boards. But I like to live in a world where it's also practical. Most of the chips that are being manufactured now, SoCs are manufactured, are all SMTs. So can't really use those in such an art form. So PCBs are OK. I usually start out with laying a schematic. By the way, all of these projects are open source. The code, the instructions, the assemblies, it's all available on my website. Also on Hackster, I believe. But yeah, I don't use Adobe Illustrator for making circuits. I use Eagle. I know people are moving towards KiCad now, but I'm still in the Eagle world. So this is more for illustrative purposes. As you can see, the circuit is extremely simple. There's a sensor, there's a power source, a dev kit, and a display. You don't have to use particle devices. You could use ESP32. You can use Seed Studio's dev kits. And then you breadboard it. I'm not one of those risk takers that directly goes from a schematic to a freeform circuit sculpture. I always do use the breadboard. just to see what the software looks like. If I need a sensor, if I don't need a sensor. For example, on this board, you'll see there's a GPS antenna. I was intending to use a GPS on this sculpture, but I ended up deciding not to because it didn't fit the aesthetics, the vibe. So I stuck, or I did not use a GPS. And then I used any ECAD tool. You can use KiCad, Eagle, Adobe, CorelDRAW to build a life-size template. It's a 2D template from different angles. It lets me measure what the actual sculpture is going to be. And then I collect my tools, very simple tools. I have a really old Weller soldering iron, which is temperature adjustable. I recently started using Pinso, which is a USB-powered, and it's surprisingly easy to use and works for these sculptures as well. So you don't have to have a fancy soldering station. Nose pliers, and diagonal cutters, and then these angle plates. You will see why I use angle plates, and then masking tape. Nothing too fancy. And of course, what is not shown here is immense amount of patience. So that I can't help with. And so the idea is basically take a printout of these templates, cut the brass stock or copper stock to size, bend it. I use a masking tape to hold those pieces together, and then apply flux. That's the key. Apply liquid flux, and apply heat. And then the solder is strong enough for these small sculptures that it will hold its shape. And then, as you can see, I'm using the angle plate on the bottom just as a plain reference if I'm making right angle joints. So that helps. And obviously, this process takes multiple hours to a few days, but it's nothing outside of this. And then you sprinkle some code. Not a software developer, so this is a means to an end. I do what I have to do. But the idea is you can do a lot if you have internet connection on your device, and which means you can fetch crazy amounts of data. Since I work at Particle, I get to use Particle devices for free or Particle services for free, and so I end up using that. But you can use something else. And you put that all together, and you have a functional circuit sculpture. At home, you will see there's a home symbol. So this is able to capture the BLE packets from the earlier satellite and display it on this device as well. I'm also getting sunrise and sunset data, but if you're a surfer, you can get tide data. If you are a pilot, you can get, I don't know, all kinds of stuff. And so there's a lot to do when it comes to repurposing this form factor to build interesting sculptures. But if you are in doubt and you're like, oh, but I really want to make a space-themed lander, you just add legs. I took my old sculptures, which were basically boxes, added legs to them, and voila, they are now landers. And so, that, by the way, is a group called Bangers. It's a binary music group. I don't have a video of them playing right now, but that's what I ended up doing with them. And that's all for today's talk. I know it was a short talk, but if you have questions or if you have comments, I also have a Discord channel that's pretty active, so folks who are interested in this hobby can log on to that. If you want free particle gear or just have questions or want to hang out, I live in San Francisco. If you're a local, we should get a coffee. And that's it. Thank you.